Hello! This is the third section of the series, Presentation and Publishing. We have a core game loop now, but we've still got a lot of polish work to do if we want the game to be as good as possible. That's what this section of the course is about. We'll step through 3 of the major tasks necessary to round out a game and make it ready to publish. Then we'll build our game for release on 3 different platforms. Before we can really call what we've built a game, we're going to need to complete its core feature set to include the basics that everyone expects, UI and audio. We'll start by implementing an audio system so that weapons will have sounds and music will play. Once the audio system is in place, we'll build our basic user interface, or UI, so that players can understand what's happening in the game. Then we'll look at performance and optimize our game so that it will run well on our target platforms. And with the game optimized, we'll go through the process of building the game for release on multiple platforms. In this video, we'll handle the audio implementation by integrating Unity's audio system into our game framework. Let's begin. Let's open the starting project for this section and get right to it. Those of you following from previous sections of the course might spot a few differences. Primarily, we've added an audio folder to the content section of our project, and in it we've included some simple music files and some public domain audio samples we can use freely to demonstrate how to implement combat sounds. Unity's built-in audio system is actually very robust, and there's a lot it can do, but they've done a pretty good job of keeping it simple to use, so don't worry about it. Still, to integrate it into our existing framework, we're going to have to make a few modifications. First, let's start by going to the Scripts, Framework, Events folder, and open the file input-events.cs. Here, we'll want to find the player actions enum, and we'll want to add a few new entries. The entries we want to add are pause, unpause, and mute. Now, let's save that file, go back to Unity, and go to the Scripts, Framework, Management folder. And here we want to open BaseInputManager.cs. Right after line 12, we want to add the following code. Then we want to go to line 46 and add the following code that I'm about to paste in. This code lets us use the escape key so that we can pause and unpause the game, and the M key so that we can mute or unmute the audio. Now, this is a mess of red lines in my IDE right now, but don't worry about that yet. We'll fix that as we go. So let's save this, then let's go back into Unity one more time, and let's go to the Scripts, Framework, Character folder, and open up the base character file. Now right after line 5 here, where we're declaring our variables, we want to add 2 more. First, we want to add an audio source called SFX source. Then we want to add a public audio clip called impact sound. Now these two together will allow a character to play a hit sound whenever they take damage, so that we can tell when the player is getting hit or when the player has hit one of the enemy AI. Alright, now we want to head down to line 25, and we want to add these 2 lines of code. This will basically take our SFX source variable, and if it's null, it will try to grab the audio source component that is on our base character. Now what this means, and here to make this easier in the future, let's add a requires component attribute type of audio source. Because this means that we're going to have to add an audio source to both our player and our enemy if we actually want this to work. When we make future enemies, this attribute will allow the audio source to be added automatically, but for our existing player and enemy prefabs, we're going to have to add them manually. Let's go to line 36 here and add these 2 lines of code first. Now this is what actually plays the impact sound when a character takes damage. And that's it for the base character file. So now let's go back to Unity and let's go to the Framework, Interactables, Weapons folder, and let's open Projectile Weapon 3D. Now here we want to go down to line 17 to the end of our public variables. And we want to declare a few more. These will probably look familiar. First, we want to declare a public audio source variable called source, which will be the source of any audio played by the weapon. Then we want to add a public audio clip called fire sound, which will contain the audio clip for when the weapon is fired, and a public audio clip variable called no ammo sound, which will be the dry fire sound, the sound it makes when you try to fire the weapon but don't have any ammo. Now let's head down to line 36 to the end of our onStart function, and we want to add these 2 lines of code. And as before with our character, what this will do is this will get the audio source component from the weapons base object, if there is one. And so that future weapons won't have to worry about manually adding them, we will once again add a require component attribute type of audio source. That said, our existing base projectile weapon and any other projectile weapons we may have made behind the scenes are going to need to have these manually added for it to work. Alright, now that we've declared all of our variables and initialized them, let's head down to line 71 of the code. And you can see we have this play dry ammo sound comment. So now let's add the code that will actually play the dry fire sound. And there you can see, if the source isn't null, and if the no ammo sound clip isn't null as well, then we just tell the source to play a one-shot version of the no ammo sound. And that's really all you have to do to get Unity to play audio. It's very, very simple. Finally, we want to come down to line 102. We'll add these 2 lines of code so that the weapon can play its firing sound when a projectile is fired. And again, it's the exact same code that we used to play the dry fire sound, except that this time we're looking at the fire sound clip instead. Let's save that file, and in Unity, go to the Scripts Framework Management folder, and let's make a new file called BaseAudioManager. And then let's open that in our IDE. First, you'll see that we've added a require component type of audio source. This way, when we build our BaseAudioManager object for in-game, it'll automatically add the audio source that we need to it. Then within the class, the first thing that we declare is a public static event handler of type AudioStateEventArgs called AudioStateChangeEvent. And don't worry about the red line. We're going to fix that after we're done with this file. Next, you'll see a header attribute defining the audio mixer properties, and then our series of declarations for our audio mixer. The first is a public audio mixer variable called main mixer, and you can see the tooltip tells you it's the main audio mixer for the game. The next is a public audio mixer snapshot called main unpause snapshot, and the tooltip here says that the unpause snapshot for the main audio mixer is what this variable refers to. The next variable that we're declaring is a public audio mixer snapshot called main pause snapshot, and again the tooltip tells you that it's the pause snapshot for the main audio mixer. Then we declare a public audio mixer SFX mixer. And here we declare a little space so that we separate our main mixer and our FSX mixer variables. And then the tooltip says the sound effects or SFX mixer for the game. Directly beneath that, we declare a public audio mixer snapshot called SFX unpause snapshot. And as you can see, the tooltip says it's the unpause snapshot for the SFX mixer. Next, we declare a public audio mixer snapshot for SFX paused snapshot, which is the pause snapshot for the SFX mixer. Then we have another header attribute, which declares our music properties. And beneath this, the first is a public list of audio clips called music clips that we initialize as an empty list. Directly below that, we then declare a public audio source music source, and this will actually be where the game's soundtrack plays from. Beneath all of our public variables, we then also declare 4 protected variables. A protected bool called _muted that we set equal to false by default. Then a protected audio state called _CRNT audio state that we set equal to audiostate.unpaused. And again, don't worry about the red lines yet. We're going to fix that in the next file. Next, we declare a protected float called _main volume level that we set equal to 0. 0 does not mean no volume, by the way. 0 is actually normal volume. -80 is actually the no volume level because we use decibels when we're declaring volumes. Directly beneath our main volume level, we then declare a protected bool called music playing that we set equal to false by default. Now we declare a region called Unity events, and in here we have our 4 basic Unity events, and each one is set to call an on version of the event. So for example, private void awake calls the on awake method, private void start calls the on start method, private void update calls the on update method, private void late update calls the on late update method. Now, once these are entered this way, you never actually want to have to edit this code again. So you can just collapse the region, then it'll clean itself up and get out of our way, and so we can work on our next stuff. Here we define another region called on Unity events, where we actually declare our on awake, our on start, our on update, and our on late update routines. Now the most important of these so far is on awake. Here we take our audio state change event handler and we add to it on audio state changed. This is a method we're going to write in a moment. Directly below that, we take the base input manager's action event manager and we add to it the on player action event method, which is another method we're going to write in just a moment. Once these 2 events are subscribed like this, then we check our music source variable, and if it's null, we set it equal to the audio source component on our BaseAudioManager object. Directly below that, onStart is blank right now. We're not doing anything with it. In our protected virtual void onUpdate method, we call handleMusic, and then beneath that in our protected virtual void onLateUpdate method is currently blank because the audio manager doesn't do anything with physics, so there's really nothing to do in the late update loop, but we've included the methods just in case that changes in the future. So that's it for this region of our code. I'm going to collapse it to get it out of our way. And then we're going to start a new region called audio events. And here we're going to declare a protected virtual void called on audio state changed. That takes in an object called sender and an audio state event args called E. Again, don't worry about the red lines. We'll fix that in our next file. So here we check to make sure that E is not null, and then we check to see if the new state passed in by E is not equal to our current audio state. If that's the case, that means we're switching audio states. And so we've set up a switch statement here to deal with the change. The first case is audiostate.unpaused. And here, if our main mixer is not null, then we call mainMixer.transitionToSnapshots, and we declare a new list of snapshots containing our unpaused snapshot, and a new list of floats containing the value 1.0, which means that we want to change to our main unpaused snapshot with a weight of 1. It's not going to blend with any other snapshots. And then finally, we pass in a 0, which is the amount of time we want to take to make the transition. Right now I have all the transitions set as instantaneous. However, if you wanted to do things like make audio crossfade or make audio fade out rather than abruptly coming to a stop, you might want to declare a little bit more time when you transition to a new snapshot to allow that to happen. Now that we've defined our main mixer, we do the same thing with our SFX mixer, and we pass in the SFX unpaused snapshot into our new audio mixer snapshot list, and again with a new float list with a value of 1 and no time. And that's the end of the audiostate.unpaused case. Next, we define the case for audiostate.paused, and here we do the same thing, except that this time we pass in the main pause snapshot in the main mixer and the SFX unpaused snapshot into the SFX mixer. The next case we define is the audio state for muted, and this one's actually a toggle. So first we check to make sure that the main mixer is not null. Then we check to see if we're muted. If we're not muted, that means we're going to be muted. And so we get the master volume's current level, and we cache that in _main volume level. Then we use mainMixer.setFloat to set the master volume to -80. Now, do you notice this string master volume here in both the getFloat and the setFloat? This is going to matter in a moment when we actually create the mixer, because by default, mixer variables are not exposed to the code for us to use in script, and so we have to manually expose them in the mixer interface. When we do, we give them each a name. And so it's important that we remember the exact name we used because we have to reference it by that name in the code in order to access those variables. Okay, finally, once we've set our mixer settings, we set the muted flag to true. And then if we're coming out of mute, we do the opposite. We take the main mixer and we set the master volume to our cached main volume level variable. Then we set muted to false. And that handles our audio state changed. Next, we want to create a protected virtual void onPlayerActionEvent method that takes in an object called sender and playerActionEvent args e. Then we check to see if the e.info variable is equal to playerActions.mute. If it is, that means that a mute request has been called. And so we check to see if muted is true. And if it is true, then we define an audio state event args called state, and we set it equal to audiostate.unpaused. Then we call our audio state changed event with that state. On the other hand, if we're not muted, then we want to do the same thing where we, instead of sending the unpaused event, send the muted event, and once again call the audio state changed method. Next, we check to see if info is equal to playerActions.pause, and if it is, then we send the paused event to our audio state changed event. Otherwise, we check to see if e.info is equal to playerActions.unpause, and then we do the same thing, passing in audiostate.unpaused into our new event arguments before we call the event, before we raise the event. Now let's talk about how we're going to handle music. Here we've created a protected virtual void method called handleMusic, and it checks to see if our current audio state is not muted, and if we're not playing music, and if we have music clips to play. And if all of that is true, if we are not muted, music is not currently playing, and we have a music clip to play, then we call a coroutine called playMusicTrack, and we send it a music clip randomly picked from the range between 0 and the number of clips we have -1 in our list of music clips. So this is actually a bit of a trick. What we're doing here is we've built the audio that we're going to use for music so that it seamlessly loops together, so that it doesn't matter what order the clips are played in. This way you can play a tune infinitely and it won't necessarily be completely repetitive. And so what we're doing here is we're saying, hey, randomly pick one of the clips to play, and then just play it. And in the actual coroutine, which is right here, it's a protected virtual IE enumerator called playMusicTrack that takes in an audio clip called target. We set music playing to true. We play that clip as a one-shot. We wait for the number of seconds equal to the length of that clip, and then we set music playing to false. And then in the very next update loop, what will happen is handleMusic will get called. And if the current audio state is not muted, and if music is not playing, and we have music clips to play, the coroutine will be called again, and it will go through it again. So this will create this sort of loop where it's randomly picking a clip of music and just playing it. And with that, we have our BaseAudioManager file. So now we're going to save this file, and we're going to go back to Unity, and we're going to go to the Scripts, Framework, Events folder, and we're going to create a new file called Audio Events. And then we're going to open the file in our IDE. Now I'm going to paste in the code here. There's actually not a lot to it, so this will be quick. So the first thing that we do after our typical using declarations is we declare a public enum called audio state with 3 values: unpaused, paused, and mute. Directly beneath that, we then declare a public class audio state event args that inherits from event args. Inside this, we declare a public audio state called new state with get and set properties. And then below that, we call public audio state event args that is empty, so that we can initialize one of these event args just as an empty class. But more importantly, we then declare a public audio state event args that takes in an audio state called new state, and we set our new state variable equal to the passed in new state inside that initializer. This way, when you initialize a new audio state event args, you can actually pass in the state that you want it to be in a single line of code. And that should clear up all of the red squiggly lines that we were seeing in the rest of the code files. So now we should be able to go back to Unity, and as you see as it compiles, all of our errors go away.